In this video tutorial, we will be talking about the impact value test, why is it performed and its testing method. So the equipment shown on the right side of the screen is the impact value test. Below you can see the tamping rod. This is the hammer, impact hammer, which is connected with the equipment and used to apply 15 blows to the aggregate sample, which is collected via a specific method. This is the safety pin, which is which is used to lock the hammer when the test is not being performed or when you are about to place or extract sample from the testing cup. More on this in the coming slides, and I'll elaborate more on the procedure. Why is this test done? It is done to see your resistance of your aggregate to impact loads. That is why a hammering effect is simulated on the aggregate. There are 4 criteria which are determined, 4 quality criteria of the aggregate which are determined. The toughness criteria is determined by the impact value test that we are performing and discussing right now. A British standard is used and not the usual ASTM or AASHTO standard for performing this test. By toughness, we mean to see how resistant your aggregate is to impact loading. Then there is the strength criteria, which we will not be discussing in detail in this course, but just to let you know that aggregate is placed in a cylindrical mold in 5 different layers, and tamping is done to the aggregate in a similar fashion as done in the impact value test. The tamping method will be shown in the coming demonstration, another video in demonstration. So the aggregate, when placed in a mold, is then subjected to a compressive stress of 40 tons for about 5 minutes. The amount of material that has broken down is then determined by and the percentage is evaluated to see how strong your aggregate is, or how does it qualify the strength criteria or not. So these are the 2 criteria, the strength criteria and the toughness criteria. Another one is the hardness criteria, which is evaluated by the Los Angeles abrasion test. This will be discussed in detail when we will be talking about experiment number 3. Lastly, there is the durability criteria or the durability performance indicator, which is determined by the soundness test. In this test, we have to see what if your aggregate is resistant to weather conditions, or a simulation of the chemical effects of the environment is done by placing your aggregate in a solution of barium chloride and magnesium sulfate for 5 days, after which again the material is sieved and we see the percentage of weight which has dissolved in those chemicals, and thereby we determine its durability or how resistant your aggregate is to the chemical action of the environment or the weathering effect. So impact value, as I have already told you, is done to evaluate the toughness criteria of aggregate, as when aggregate will be placed in the pavement, it will interlock amongst itself along with the binder which will be placed in the asphalt, essentially when you make an asphaltic pavement, aggregate and bitumen combine to make the asphalt. So while the aggregate is interlocked amongst itself, as well as bound by the bitumen which is placed in it, it will be subjected to impact loads or compressive loads when the tire of the road will pass over it. So that is what we are trying to determine, if your aggregate can withstand that load or not. So to evaluate it, we take about 350 grams of material passing 14 millimeters and are retained on 10 millimeter sieve. These roughly equate to the half inch and 3/8 inch sieves of coarse material. Secondly, after acquiring the material, we place it in the sampling cup and place the aggregate in 3 layers. Each layer is tamped 25 times. The tamping and the placement of the aggregate in layers will be shown in the lab demonstration video. So, after placing the aggregate in 3 layers and tamping it in the sampling cup, it is then transferred into the testing cup, in which the 14 kilogram hammer is then dropped 15 times from a drop height of 38 centimeter. Now, although this drop height is constant, because once the drop height has been set in the equipment, we do not change it, but you will see the procedure of the setting of the height as well. After which, once the aggregate has been subjected to 15 blows of the 14 kilograms hammer, it is then passed through a sieve number 8, which is used to see how much of your material has essentially been broken down or disintegrated under the impact of that hammer. If the percentage of material that has broken down divided by your total initial weight, which you have placed in the testing cup, will give you the percentage of the impact value. This percentage should be less than 30%, and if your percentage comes out to be more than 30%, then we do not use the aggregate for placing in our road. That is, it has failed the impact value criteria. And even if it is less than 30%, we try to take the aggregate which is the most tough, because we want that it can bear load as much as possible. So, there are 3 sub criterias, that is, if it is less than 10%, then it is exceptionally strong, 10 to 20 is strong, and 20 to 30 is satisfactorily strong. Although the values that usually come during experimentation lie somewhere between 20 to 30, it is around 22 or 24%, but we use it so that we use it for placement in the pavement. And here are some criterias against the type of layer in, or the type of road which you wish to place the aggregate in. And on the right side of the table, you can see the passing criteria. For instance, if we say that you are to use the aggregate in bearing course, then your impact value should be less than 30%. Similarly, for water-bound macadam base course, you can use an aggregate which has up to 40% value.